Okay, so today you're going to have to kind of skip around in your notebook. So this right here, this section we're doing right now, this is before the division. So if you want to pause the video and find that, you can. There's a couple examples I want to do with you about finding zeros of a function. Remember that zeros are your x-intercepts, okay? And we talked about yesterday or the other day about linear factors of solutions, and it's just when you write it in factored form. So that's what we're going to do right here. And I'm just going to do a couple examples here. So remember, when you factor, your first step is to take out a GCF. So on this one right here, we have a GCF of x. So when we divide all of these by x, we're left with x squared plus 3x minus 10. And then we'll go ahead and factor. Remember, bring down this positive. Positive times negative is a negative. What times what gives you 10? When you subtract, give you 3, and that's going to be 5 and 2. So this is all in factored form. Now remember, our highest exponent here is a 3, so we're going to have 3 zeros. So if I ask you to leave it in factored form, it would look like this. And so I would need to set this plain old x equal to 0, which gives me 0. Set x plus 5 equal to 0, which would give me negative 5. And this answer would give me a positive 2. Okay. Let's look at number 3. When you have x to the 4th power, we can factor this, and we would just split x to the 4th to be x squared and x squared. I bring down this negative. Negative times positive is a negative. Well, what times what gives me 4? When I add, give me 5. That would be 4 and 1. Now, since my highest exponent is a 4, I know that I'm going to need 1, 2, 3, 4 solutions. So remember what I said the other day, if you ever have x squared, you need to see if it could be factored some more. And so this is a difference of 2 perfect squares. So that could break down to be x plus 2, x minus 2. And this x squared minus 1 could be x plus 1, x minus 1. And if I find my zeros, this would give me negative 2. This gives me 2, negative 1, and positive 1. Now, what I want you to do is I want you to look at this word multiplicity. And what this means is when it repeats. So when I factor this here, and I'm going to take out an x, and I'm left with x squared plus 10x plus 25. When I factor this, it's going to give me x plus 5 and x plus 5. So in factored form, I have x and x plus 5 squared. Now I know I'm going to have 3 solutions. So if I was to solve this, I would get 0, and here negative 5 and negative 5. But instead of writing negative 5 twice, my zeros would be 0 and then negative 5, multiplicity of 2. So when it repeats, you put multiplicity of and how many times it repeats. Now the thing is when the multiplicity is even, meaning it repeats twice, 4 times, 6 times, it's an even number, the amount of times it repeats, it means it's going to bounce. So it bounces off the x-axis at that 0. So this one right here, if I factor this, I would take out an x, and I'd be left with x squared plus 4x plus 4, which would be this. So my zeros are 0 and negative 2 with a multiplicity of 2. It repeats twice. So what that means is I would have it at a 0 and negative 2. Well, since my highest exponent is a 3 and my leading coefficient is positive, I know it's going to rise from left to right. So since the negative 2 repeats twice, it means it's going to bounce off of it. And since this one only is once, that means it crosses through. So let's solve this right here. If I set that equal to 0 and solve, the 0 is going to be 1, and the exponent is 2, so that means it has a multiplicity of 2. Since your multiplicity is an even number, it's going to bounce off the x-axis. This one here, if we set that equal to 0 and solve, that would give us 3/2. It will repeat 2 times. Again, since it's even, it's going to bounce. The last one here, if we set x plus 4 equal to 0 and solve, we get a negative 4. This exponent is 1, it's even, so it's going to cross through. So let's look at this one here. So step 1, I want to take out a GCF, which is x cubed. So if I take out x cubed and I divide this, and this by x cubed, I'm left with x squared plus 8x plus 16. And when I factor this, it will give me x plus 4 and x plus 4, which I would write, I'd write it at x plus 4 squared. So we would set this equal to 0 and solve, which would just equal 0, but it would repeat 3 times because my exponent is a 3. This one, if I set it equal to 0 and solve, my 0 would be negative 4. Since the exponent is 2, it's going to repeat twice. So if the multiplicity is an odd number, it crosses through. This one's even, so it will bounce off the x-axis. The last thing I'm going to show you is how do you use zeros to write a polynomial function. We are going to leave everything in factored form. So remember, if I have x minus 1, we do the opposite and our 0 is 1. So you're always going to do the opposite sign. So if my answer is 1, one of my binomials would be the opposite of that x minus 1. In order for me to have a 2, I would do opposite of that positive, x minus 2. And to have a 5, it would be, x minus 5. Because if I set those equal to 0 and solve, it's going to give me positive 1, positive 2, positive 5. Let's look at number 3. In order to have an outcome of a negative 2, I would need to put the opposite, x plus 2. Now, when I have a negative 4/3, this is where the bottoms up helps you out. Because we do the opposite of negative, we have x plus 4/3. Well, if I want to know what the binomial is, I put bottoms up. So it's actually 3x plus 4. You don't want to leave it at an x plus 4/3. And then in order to get 2 as my answer, it's going to be x minus 2. Now, one thing you need to know, and I'm going to cross out, just add something. If you ever have a square root of 3, so whenever you have a radical, you automatically have a negative square root of 3, because whenever you square root, your answer is always plus or minus square root of 3. So just remember, if that's one of your zeros, you automatically have a negative. That only works for radicals and i's. So you could actually say x minus square root of 3, and that would be x plus square root of 3. Now, if we chose to multiply this out, which you could if I asked for it in standard form, this, since they're conjugates, remember you could do the shortcut, and it's x squared minus 3. Because if we set this equal to 0 and solve, we would get x squared equals 3, square root both sides, and that's how we get plus or minus radical 3. We haven't worked much with i's because we haven't done complex yet, but we will. So let me just so if you ever have an I, you would automatically have a negative I. And remember, I is whenever you have a square root of -1. So then you would write it as x minus I and x plus I. And if you were to multiply this out, x times x is x squared. This would give you negative I squared. And remember that I squared equals -1. And that would be your polynomial. So, what are we going to do when we see multiplicity? So when it says 3 multiplicity of 2, well, we would just do the opposite of 3, so x minus 3, and we just put a square if it's a multiplicity of 2. And then this says 5, so it would be x minus 5. Number 8, when you have a 0, you would just put x, because x would be equal to 0. In order to get a 1, you do x minus 1. Now, in order to get 5 halves, remember you do the opposite and then you do bottoms up. So it will be 2x minus 5. And if it's a multiplicity of 2, you just put an exponent of a 2.